All right, so in this video, we're going to talk about the precise definition of a limit. We're going to talk now the formal definition as opposed to the informal that we've studied in the last few sections. And so the formal definition is given epsilon, that's the Greek letter epsilon, bigger than 0, there exists a delta, Greek letter delta, bigger than 0, s period t period means such that if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. Now, this is a definition that allows us to avoid saying arbitrarily close like we did in our informal definition. This gives us now a really precise way of identifying how close is close enough. And so epsilon and delta. Anytime you see deltas and epsilons, in particular in calc like this, we're talking about really, really, really small positive numbers. So given a really small positive number, there exists another really small positive number such that this, then this. Now, if you remember, the absolute value of x minus a, that just represents a distance. Same thing here, absolute f of x minus L, that's a distance. So given a small positive number, there exists another small positive number such that if the distance between x and a is less than delta, then the distance between f of x minus L, f of x and L is less than epsilon. Okay, so these statements are less than small positive numbers, less than small positive numbers. So you can see we're really dealing with things close and really tight into our picture. And so speaking of the picture, let me draw the best picture I can statically. I would strongly encourage you to get onto YouTube and type in formal definition of a limit. There's a lot of good stuff on there that's dynamic and the fact that it moves around and it's easier to better visualize. So I'm going to go ahead and draw a little picture here. I'll put an open circle there to add a dramatic effect. And so if this is y equals f of x, then this guy here being our c, and this guy here being our L. So what I'll do now is I'll go ahead and I will drop down from here, and I will also drop down from here. These x values will be my c plus delta and c minus delta. As I come across now, these y values will be my L plus epsilon and L minus epsilon. So what's happening here is it's an if-then statement of the sorts. If the distance between x and a is less than delta, then the distance between f of x and L is less than epsilon. So I'll start over here with the distance between x and a. And I've just realized I keep saying A, but I've used C in my picture, so that's clearly my mistake. Let me go ahead and mark that as a C right there, not an A. You can see I've used a C down here as well. So distance between X and C is less than delta. So what's happening is if I take both of these guys, let's say that I have two hands, and I take both of these and I pull them together. If I pull these things together and approach on C, well, what's happening with these right here? If I pull these together, these guys are actually getting closer and closer to my limit L. So by pulling the the C plus delta and C minus delta together along the x-axis, it then in turn pulls together the L plus epsilon and L minus epsilon together on my y-axis. And that's going to allow us then to zero in on our actual value, our actual limit. Okay? An example that I can give you from the text is example 2. So, example 2 on page 58. It goes up to the top of page 59. That's going to be another example that I think you'll benefit from seeing as well as we would then now move into working some problems. But I know it's kind of a hard idea to represent on a whiteboard like this, so I would really encourage you to get onto YouTube and try to actually find some videos where things move around, and it'll help you hopefully better understand what's going on. Okay, so the type of problem that will work out of this section will be to prove a limit. we're going to prove the limit as x approaches -1 of 7x plus 5 is equal to -2. Now this is an actual proof. Okay, we're told to prove it. We're not just going to take the -1, plug it in there, and show that you get a -2. That's great that it works, but that's not our job here. Our job is to prove it. So there's going to be two steps in this actual process, one of which will be the proof itself. So I'll say for step 1, our first job is to find delta. Now, to find delta, we're actually going to start off with the idea that the absolute value of f of x minus L has to be less than epsilon. Now, if you look at what we're given in terms of the limit to prove and the traditional notation we've been using, the limit as x approaches c of f of x equals L. Our function would be that 7x plus 5. The L value in our case would be a -2. And so by plugging that in and simplifying a bit, I get the absolute 7x plus 7 is less than epsilon. I factor the 7 out, and I divide it off. And look what we just came up with. We just came up with now the x minus c is less than our delta. So that guy right there, because we know again this is x minus c, our c value was -1, we know this has to be equal to our delta. Okay, that should happen every single time. If we follow step 1 like I've shown you, you'll always end up getting your delta right here. Now, that doesn't mean it's the only delta. That means it is small enough to actually work. And so, provided our delta can be epsilon over 7 or less, then we're good. Okay, so that's step 1. Step 2 is the actual proof. And the proof is very mechanical. We'll say given epsilon bigger than 0, let delta equal epsilon over 7. Then remember the if-then statement. If x plus 1 is less than delta, then the absolute x plus 1 has to be less than epsilon over 7. And so from there, if I multiply the 7 over, feels like we're just working step 1 backwards, and we are. That's exactly what we're doing. We're working step 1 just backwards. I'll distribute that 7 in there. Then I'll go ahead and take the 7x plus 5 minus a -2, just like I did from above, less than epsilon. And so there you go. You've proven that given epsilon bigger than 0, there exists another really small number, delta. If x minus c is less than delta, then f of x minus L is less than epsilon. So again, very mechanical, step 1, step 2 stuff. You're going to benefit greatly by looking up some videos on how this moves around. You'll also benefit greatly by looking at the homework on my math lab. They have some really good problems that I've assigned that will help you better understand what everything stands for and how it works together in order to justify what a limit actually is for a particular function.